What's going on, arcade nerds? I just picked up a Tempest, and I got it on the cheap because it doesn't work. I happen to have a working Tempest board, but you know. So anyway, so I plugged it in. We have a monitor problem. So in this video, let's get this damn monitor working. Okay, so right now we're behind the Tempest machine. And the first thing I'm going to do is I'm going to go ahead and unplug the one connector that connects to the monitor. Normally you'll see this in here, yeah, but someone did not put it in. I myself don't put them in, so whatever, it's okay. Now I'm going to, oh, you know what? You know what? Let's talk about discharging the monitor first, right? Hold on. Okay, well, I got myself a little bit of solder. I'm going to break off a little piece of it. Okay. I'm going to get a flathead screwdriver. I'm just going to wrap a couple windings around it. And the metal frame, I'm going to put a couple windings of the solder around that. Now, I happen to know this isn't charged, but just because, for any of you that you know are worried about working on these things, I strongly suggest it. Now, I did this exact thing in a video before, and someone was like, "Oh no, you can't do that bare solder wire," and so on. But honestly, it's totally safe. As a matter of fact, you can hold this bare wire as you discharge it. Although I shouldn't tell you that, right? But anyways, okay. So we're discharged. I just touched the anode cup, the anode button in there. We're discharged. Okay, so I'm going to pull off the socket. I'm going to take off this connector right here. I'm going to disconnect every plug. That one's for the yoke. This, and this, and this. And I'm going to take off the decals, coil. Okay. Now, see this one plug going to the high voltage? I'm going to unplug that. And, okay, we have two options at this point. At this point, we could take a screw out, a ground screw, and take this entire neck with me, and take it with the chassis. But what I'm going to do is, by the way, not all of these have this, I'm going to take off this little plug right here. Okay, I'm going to take off this little plug right here. Take off this little plug right here. Now the deflection board is freed of the neck board. And by the way, these three plugs are actually labeled on these terminals are labeled. One will say brown, one will say black, one will say white with blue tracer, right on the deflection board. So now I have a 1/4 inch nut driver. Take off this one. Take off this one. Okay, and it should come right out. There's nothing on this board that can shock you. No worries there, okay? Okay, so let's get this on the bench. Okay, so we have the deflection board out here on the table here. I'm going to get my meter. We're going to set it for continuity test. Okay, the first thing I'm going to do is I'm going to test the fuses. Even if they look good, I'm still going to test them. But I'm going to test them in circuit with the fuse holder. Now, you could just test the fuse itself. Right there, that's good. But what I'm doing is I'm testing the fuse holder to fuse holder. That way we're testing the connection between the fuse and the fuse holder itself. Okay, so that one's tested good. That one's tested good. That one's bad. And that one's good. Okay, so we have a bad blown fuse. What does that tell us? I'll tell you. Okay, I'm going to pull the fuse. Okay. On your deflection board, if you have a blown fuse on this side, that means follow the cable, this cable here, this plug, to the transistors and replace both transistors. If you have a blown fuse on this side, follow this cable and replace those two transistors. Why am I telling you to replace two transistors? Well, I'll tell you why. Those transistors should be replaced in pairs. If you do not, there's a slight possibility that deflection on one axis might be a little stronger or weaker than on the other axis. So when you replace these transistors, replace them in pairs. Now, odds are the transistors on this side are totally fine. So I'm going to leave them alone. You know what I mean? But obviously, one of these transistors was shorted, and that's what caused this fuse to blow. Okay, so we know that's one issue, and I'll remember that, and I'll come back to that, and I'll have to get on the chassis itself and replace those transistors. Another clear, obvious, terrible-looking thing here is the low voltage section. It looked like someone replaced some resistors here at one point, and there's a fried, oh god, a really fried resistor here. And so what I'm going to do is I'm going to put in an LV2000 kit. You can buy these through Arcade Shop, and I'm sure there's others that sell it, but Arcade Shop is my favorite. This specific one is not an Arcade Shop, but I like the Arcade Shop version better. But they're basically the same exact thing. What this is a little circuit that's going to, okay, remember how I talked about how there's two transistors right here, there's two transistors right here? Well, this circuit connects to another two transistors, and those transistors are connected directly to the line voltage. So you have, what is it, 30 volts, and it's going to regulate it down to about 27 volts. Okay, and these transistors are acting as a switch, and this circuit is controlling the switch. So you have your base collector and emitter, and depending how much this turns each base on, it will connect the collector and emitter together, kind of like a dimmer switch. And the reason this is here, to be honest, the major difference between this and an ampliphone monitor is an ampliphone monitor doesn't have this. They actually short it directly through, so there's no voltage regulation. So why is voltage regulation necessary? I'll tell you why. Let's say you have a refrigerator connected to the same circuit. Okay. Well, every once in a while the compressor is going to turn on the refrigerator, and it will drop the voltage in that circuit in your house down. Let's say 5%. Have you ever seen this on a TV set? Let's say something with a large, especially inductive load will turn on, and it'll dim your TV for a second, or dim the lights for a second, or whatever. This is meant to actually regulate the voltage and give a little more, so let's say if it regulates it to 27 volts, but you have 28 available, you can still have 27 volts. Does that make sense? I hope it made sense. But okay, so I'm going to do. I'm just going to literally, and you can desolder these, but what I'm going to do is bust these off. I'm going to cut that. I'm just going to get this guy right here and cut all this stuff. We no longer need it, because this LV2000 kit we're going to put in there is going to replace this whole section of the kit. Like I said, the difference between a 6100 and an ampliphone is mainly the absence of the voltage regulator circuit. But another reason why you should never bypass it, you could, but you should never bypass it on a Wells Gardner 6100, is because an ampliphone has way better cooling. It actually has a giant heatsink and so on, and so it can handle that extra 10% of voltage. So long story short, if you had adequate cooling, you could bypass this, but I'm not going to. There's no reason to make this, to bypass this. Okay, so this is removed. This is removed. This is removed. Okay. So now what we need to do is clear out some holes. We're going to clear out this hole. It's hard for me to tell. Yeah, okay. This hole needs to be cleared out. Let me try to zoom in. See if that makes... I should have had it that way all along. Okay, but now we need to clear out this hole, and this hole. Okay, and these three wires are going to go through those three holes. Now we got to clear out this hole and this hole, and these two wires are going to go through those holes. Okay, so let me heat up the desoldering iron and let me clear out those holes. Okay, I cleared out these holes, and you can put this directly down all the way flush, but I don't like to do that. What I like to do is I like to put spacers, and what I'm going to do here is I'm going to put 3 perler beads right here. Okay, and I'm going to line up these holes. Just like that. Okay, those 3 holes are lined up. Now my black wire, hold on, let's line them up. Red wire is over here, and black wire is right here. Oop, came out. You may not see them in the camera, but the LEDs are actually lit right now. I can't see it in the viewfinder at least. That's because there's some charge left in these capacitors. I'm going to flip the board over, and I'm going to bend these out. And I'm going to solder it on. Now, when I do this soldering, here's a fair warning that I'm using some 25-year-old solder. At least, and it doesn't really stick because I'm out of regular solder. So I ordered some solder. Kelly, you ordered that solder, right?
Yeah.
Okay. My wife ordered some solder, and so every once in a while I go back to this old nasty roll, which doesn't stick. Terrible, terrible solder. So see how it goes. Okay. I really couldn't think of a video to do. It'd be interesting, and I've covered this exact same thing in videos before, but you know, I don't know, I just figured, you know what, I'm going to do something, let's just record it. So that's what this is. Okay, so now my LV2000 kit is soldered on. And let's see here. I'm gonna find a fuse, of course, to put here. Where's the original? What is it? I think it's 3 amp or something. What is it? I'm looking through the fuse. I think that's a 3 amp. What's this say? Okay, I can see it's a 3 amp. So I'll find me a 3 amp fuse. We have our LV2000 now soldered on. This is not going to fix the the machine know. I can tell you that right now, because this fuse blew for a reason. Oh, you know what? Let's go over this. Since we have this board out, all these solder joints commonly go bad. And when I talk about solder joint is you have a through hole, and then you have a through hole, and you got the pin that goes in the through hole, right? Well, over time, the solder joint will crack because the pin has been moved. Okay, and it gives a bad connection. So, commonly, I go over all these solder joints, all these spots right here. Okay, let me move over here. See, oh, right there, there's one. Can you see it? See how there's a ring around there? That means it's cracked. So, let me go over that with my crappy solder again. I'm soldering with my hands stretched way out because the camera is right in my face. Okay, so I'm back behind the machine here. Now remember I talked about that one plug that had the blown fuse? This is it right here, okay? Now there's 6 wires going to this. One is going to an NPN trans, 3, and you can separate this in 2 groups of 3. 3 of these wires are going to an NPN transistor, and the other 3 wires are going to a PNP transistor. Okay. So what I'm going to do is I'm going to set my meter to diode test. I'm going to treat these transistors as if they're diodes. Okay. Now I don't have to measure the back of the case because these wires are literally going to the case transistors. So I'm going to probe around until I find it. Oh, found a short right away. Okay, so that is the reason our fuse blew. I'm going to check the other one. I'm going to replace them both, just because I'm going to test the other one now. They are both shorted. Okay, well, that's all you need to know with that. Matter of fact, if I would have put this to continuity test, I bet you I would have had a beep. Yep. Okay, so those 2 transistors are shorted, and we're going to replace those 2 transistors. Okay, so I have a brand new 2N3792 and a brand new 2N3716. So I'm going to follow this cable. I'm going to pull this transistor right here, take the screw out, take this one out, and I'm going to pull it right out. It's in a socket. Okay, so the transistor I pulled out is a 2N3792, and it looks like I didn't damage my Mylar, so I'm going to reuse that. And I'm going to get some thermal compound right here. I'm going to put some on this side of the Mylar and some on this side of the Mylar. You don't have to go nuts. Okay. 3792. Now if you notice these pins are offset, you want to make sure the holes line up like that. And I'm going to plug the new one right in. I can see it. There we go. So I'm going to put this in. Now sometimes when you put these in, you can kind of go by feel. If they slide into the socket too easy, you may need to bend the clamps on the socket a little bit so they clamp again. Or if that does not work, sometimes I will solder wires directly to the bottom to make sure that they actually do have a good connection. I'm only going to get these just finger tight. You don't have to go nuts and like over tighten these. You just need to be a little tight, a little snug. Okay. Now I'm going to grab my meter. I'm going to set it to continuity test. If you don't have continuity test on your meter, you can set it to read resistance. Okay. Now, what you want to do is you want to put one wire on the chassis, the metal frame, and touch the top of this. See, I have no continuity. And also, I'm going to touch the back of these wires. No continuity. See, there's technically 3 wires on these transistors. One wire is tied to the metal case. So this metal case is considered a wire. And then you have 2 wires right here. You basically want to touch each of these and touch the metal case when it's installed to make sure that none of these are shorted onto the metal case. Okay, so let's follow this wire. Now we have to get this transistor in here. And I dropped my meter. That is already loose. How do you like that? Loose as hell. Wasn't even tight. Okay, let's pull this one out. Okay. Same thing. I'm going to coat the mylar with some thermal compound. Line up the holes. Stick this one right back in. Hopefully we'll find some other issue so I can show you something else to do. Oh, I don't even know if this high voltage works or not, but what I'm going to do is I'm going to put one of the brand new replacement high voltages, because that's what I want to do. If this doesn't work, if it works, I'll leave it alone. Okay, so that's that. Let's go ahead and put this in. Okay, I have my 2 screws here. My 1/4 inch. I'm not going to go nuts. I'm just going to let it sit there because there's a possibility something else will be wrong and I'll have to take it back out. So that's just a mock-up for now. Okay, and I also need to go pick up a fuse real quick. Probably steal one from a non-working 19V2000 for now. Okay, this plug does my voltage transistors right here. This plug powers my high voltage. This plug is X deflection, and this plug that I'm putting down here is Y deflection. And of course I have the Gauss plug that goes up here. And then I have these. Okay, this is labeled right on the board. I have brown wire. We're going to put the brown wire here. And on the board it says white blue. White blue goes where white blue says. And another one is black. Where is it? Looking at my bald head, aren't you? Alright, now black. Okay, so let's put the neck on. I'm going to get this wire, my colors for the guns. I'm going to connect my power to the high voltage. And let me find a fuse and let's turn this sucker on. Okay, so I wanted to videotape this while I turn it on. And let me give you guys a tip. Right now it's plugged in, but the interlock is off. That's the switch on the back of for the back door. I want to watch the fuses and watch the board when I turn it on. Because if something smokes or fries, I'll know exactly where it happened, so I know where to look. Okay, so here we go. I'm going to turn it on. I have no spot killer, but I do not hear chatter either. Kelly, can you go in the front and coin it up?
Yeah.
By the way, I have a vector breakout. Okay, so it is working, but I have no spot killer and no. I didn't hear high voltage either. I'm going to turn the high voltage up. Do you see anything, Kelly? Okay, so odds are we might have an issue. See anything now?
No.
Okay. So we probably have an issue with our high voltage. And we still have another deflection board issue. Okay, let me shut it off. And let's take a look. Okay. Since we have no deflection, I'm starting to wonder if the power transistors are bad. Because you don't need these. Okay, remember I was talking about how the transistors are turned on just enough to regulate the voltage? Well, you don't. You know, a lot of people believe that just because they see that these two LEDs lit, that they have power, but that's not necessarily true. For example, okay, this regulator controls these transistors that are connected to this wire, right? Well, I'm going to turn it on now. We have LEDs. Well, that doesn't mean that it's controlling these transistors that is delivering power. So I'm starting to think that might be it. That maybe before that one fuse blew, it took the power transistors with it. So I'm going to set my meter to diode test again, and I'm going to test if I can get this to stay still. Okay, so I'm going to test. Remember these three wires on one side, and these three wires go to one transistor, and these three wires go to another. So I'm going to probe around. Okay, nothing. I'll go over here. Nothing. 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 Okay, move over here. Nothing. And one reading. Okay, so let's read that. And let's move this over. Nothing. Let's go to this, and let's move this over. Okay, so you see how the meter said 0.5 for a second? I tried every possible combination, and I was only able to read 0.5 one time. That means that this transistor is opened. Okay? So we have one open transistor, and I suspect we'll have a second. Okay, so let's Test from here to here. Here to here. Okay. Here to here. Okay, 0.2 doesn't sound too healthy. And here to here. Here to here. Here to here. Okay, yeah. We have 2 opened transistors. So that means I'm going to have to replace both power transistors as well. So I figured there's going to be more problems. It's never that easy sometimes. So let's see here. Let's pull this back off. You take these screws right back out. So what I'm going to do is I'm going to move this aside, and I'm going to go ahead and replace. Kelly, can you see the transistors? I'm going to replace this transistor. Hold on. I'm just going to go ahead and do this off camera. I'm going to replace this transistor and this transistor because they both test bad. Okay, so I replaced those 2 transistors and putting it back together. I'm just going to put 1 screw in for now. Okay, let's put all these back together. Okay. Okay, plug this in. Okay, and every time you mess with things like monitors and so on, always watch the board when you turn it on. Make sure we see no sparks. Okay, I'm turning it on. Ooh, I heard high voltage and I hear deflection. Anything?
I'm waiting.
I'm going to turn the brightness up, the fly back up.
Alright, good.
See anything?
Yep, and it's fuzzy, turn it down.
Okay.
Down more.
Down more.
Right there is good. And it's fuzzy.
It's fuzzy?
Yeah.
Okay, hold on. Okay. Yes, it's fuzzy. Adjust the focus. You're way out. Right there, dead on.
Okay.
Beautiful. Why do I see this crazy line in the picture? It's the
Yeah,
I guess
it's
it's
the
the
outline.
No, I'm looking at the reflection of Centipede.
Oh.
And
I see.
awesome. Awesome. Okay. Well, that's that. Damn, I was hoping there's something else I could do. I guess that's it. I gotta adjust the board, make the monitor right. But yeah. Oh, did I explain what I'm doing with this? Yeah, I already have a Tempest, right? I have a Tempest, and Clay Calgill made a game called Vector Breakout that runs off Tempest hardware. So I want to make a dedicated Vector Breakout. And I'm going to have a escape pod do the graphics for me. I'm going to have custom artwork for the marquee and for the control panel. And yeah, that's that. Well, alright guys, if you like this kind of stuff, give me a thumbs up. Please subscribe, hit that bell icon, and have a good one, guys.